If you are a developer building containerized applications on AWS, you know that it can be a complex and time-consuming process to manage all the infrastructure and deployment tasks. From setting up clusters to configuring load balancer and scaling, there are many things to consider. That's where AWS Copilot comes in. Hello everyone, welcome back to my channel. Today we're going to learn AWS Copilot, a powerful command line interface tool which helps you automate deploying containerized applications on AWS. With AWS Copilot, you can focus on writing code and delivering features, while the tool takes care of the infrastructure and deployment details. Are you ready? Let's get started. There are several key concepts you need to understand before using AWS Copilot. Application. An application is a collection of services and environments. Once you have your application created, all of the resources and services will be deployed into this application. In our example, we will create an application which is called Start Quick App. Environment. Environment is specific configuration of the applications, such as staging or production. Each environment has its own set of resources, and Copilot manages them separately from other environments. In our examples, our test environment includes a secure network such as VPC and subnets and security groups, an application load balancer, and some other resources. Service. A service in Copilot represents a single component of your app, such as a web server. Once you deploy a service in the environment, Copilot will build the image, push it to Amazon ECR, and set up the required infrastructure for running the containers. In our example, we'll build a Django project using Docker Compose locally and deploy it using AWS Copilot. Other than these things, I will show you how to easily build a CI/CD pipeline using AWS Copilot with just a couple of commands. The required code is in my GitHub repository, and you can find the URL in the description. Now, let's just move to the hands-on part. In this video, we use Django, which is a web framework based on Python. The branch name is Django Start, which includes the Django code, Docker file, and Docker Compose file. Now, let's open up a terminal and go to the folder for cloning the code. Here I use -b to specify the branch name. Once it is done, I'll just go to the folder and type code dot to start VS Code. Now VS Code is ready, and let's start a new terminal. Here you can see we have Docker file for building the image and the Docker Compose YAML file to start your local dev environment. If you're not familiar with Docker Compose, you can check out my video about how to use Docker Compose. In the Docker Compose file, you can see we have two services. One is the Django service, which is going to be built via the Docker file we made, and the other one is the database service for local. Then let's check the Python environment for our Django project. We have requirements.txt, which includes all the libraries and packages we need. In the settings file for the Django project, I have updated the database part with environment variables, which we can pass the values in via Docker Compose as well as AWS Copilot during deployment. Now, in the terminal, we can just run Docker Compose up -d --build with a few seconds, and the environment is up. Let's go to the web browser and type localhost 8080. You can see the site is up and ready for your local dev work. Now we're going to use AWS Copilot to deploy the site to AWS Container Service. The first thing is to make sure you have AWS CLI v2 installed and the credential is properly configured. Also, you need to have Copilot installed as well. Here I use version 1.27. Then the next step is to create an application. We run Copilot app init and then type Start Quick App as the application name. The AWS Copilot will help us set up the application, and you can see a workspace file was created with the application name in it. The process takes a while, and once it is done, we can just run Copilot app show to see the details of the app. Now we can see we have a brand new app with no environment, workloads, and pipeline setup. Then the next step is to create a test environment within the application. Then I will use the default profile for the AWS credential here. And for VPC, we just use default here as well. Then it will also takes a while to run, and during the period of time, we can see a manifest YAML file was created in the test folder under environment directory. Click the manifest. It has name and type, and the network is used for setting up the VPC and subnets. HTTP is used to set up the load balancer. I will pause the videos here until the initialization process finishes. Okay, now the environment init is done, and you could see we can update our manifest file and run the environment deployment command. Here you can actually use your existing VPC, but for us, we're going to create a new VPC and let AWS Copilot to manage it. I will add the CIDR block for the VPC and the subnets. For the load balancer in this example, we're going to use our own domain to present the website. So here I need to add the SSL certificate for the load balancer. We need to add the ARN of the certificate. Actually, I have set them up already, and I'll show you where you should go to find it. Let's go to our AWS console. Then firstly, go to Route 53. You can see I have cloudcracker.click, which is my hosted zone. Then let's go to Certificate Manager. And here you can see I have created a certificate which includes the domain name for the hosted zone. Then we just copy the ARN and we paste it here in the manifest file. Then let's run Copilot environment deploy --name test to deploy the environment. Now you can see a list of the tasks for the infrastructure creation process, such as VPC, subnets, security groups, IAM roles, etc. It'll take some time to run. Let's go to CloudFormation. We can see the stack for test environment is here. Then let's have a look at resources within this stack. We can go to AWS VPC and we can see we have a newly created VPC. Click the VPC. We can see now AWS provides us a new way to view the network resources, which is called Resource Map. Now we go back to the terminal. Before we deploy the service, we need to have our database ready. Here we use Amazon RDS, which stands for Relational Database Service. We'll use AWS command line to create the database instance and its required resources. Yeah, you can also use the console to create the resources by yourself. The first step is we need to create a database subnet group, which is used for the database to be provisioned, and here we selected the private subnets. Then we need to create a security group for the database. Once it is done, you need to record the group ID, which is the output of the command. Then let's have a look at the security group. You can see we have a security group which is created by AWS Copilot and called Copilot Start Quick App Test Environment. This one is used for the containers within the service. We need to allow the security group as the source group to our database service via port 3306. So we create the ingress rule. The source group is the security group for the service, and the group ID is the database security group you just recorded. Now it is time to create the RDS instance. Regarding the master username and password, we just use the values same in the Docker Compose file, but for your deployment, you better use other ones. Also, if you specify a DB name flag, RDS will create a database when the RDS instance is created. If you have an existing database, you can just skip this part. Then create. Now we can go to the RDS service, then go to the database instance and check the configuration. Remember, we will use the database username and password and database name during deployment of the service. Back to the connectivity tab, the endpoint does not show anything as the database is still being created. Let's just speed up the video. Now we can see the endpoint, and this will be used as the database service variable. Okay, the database is ready. Then we go back to the terminal. It's time to create and deploy the service. Let's run Copilot init. Here we can see different types of workload, and as we are building a website, we select load balanced web service, which means internet to ECS on Fargate. Then let's give it a name called Django site Then for the Docker file, we select the one in the root directory. Okay, great. The deployment started. Then another question is popped up and check if you want to deploy to test environment. Remember, we have created an environment called test, so we just type yes. Then the build and deploy process started. It takes some time to build and push the image, but you can see an error occurs, which is due to missing alias with certificate imported. Here we need to check the newly created manifest file with the Django site service folder. Here we can see the environment section, which is used to override the values defined already. This is what we are going to do. We add alias www.cloudcracker.click here, and for the hosted zone, we need to go to Route 53 to get the hosted zone ID. Other than this, we can add the health check for the target group to monitor the status of the container. Also, we have redirect to HTTPS enabled. Regarding the variables, as I mentioned just now, we need to set up the database related variables, which are the same as what we use in the Docker Compose. The only thing we need to change is DB host, which needs to be replaced by the endpoint of the RDS instance. Then we run Copilot service deploy --env test. It takes quite a long time to run, and let's just pause the videos here. Now you can see the running task is 1. Actually, we can try to access the site. Open up a browser and type www.cloudcracker.click. Seems like we missed some configurations on Django settings. Let's go to settings.py and scroll down to allowed host. Here we will add IP address, which is the internal IP that is assigned by the ECS service. Localhost is used for troubleshooting when we need to access the container directly, and the customized domain for the website. Let's cancel the deployment, run Copilot service deploy again. Wait a few minutes, and then we're running into another error which says the service is being updated and cannot be deployed to. What does it mean? It means even if we cancel the deployment via AWS Copilot command, the CloudFormation is still in the running status. Let's go to CloudFormation, and you can see the stack status is create in progress. The way we can fix it is to update the running service with 0 desired task. Then you can see the pending task is gone. We go to the stack page and refresh. The stack status is changed to create complete. The failed task will always cause the service restart a new task until CloudFormation deployment times out. So when we change the desired task to 0, CloudFormation consider the service creation is done. Then we go back to the terminal and rerun the service deploy. Now you can see the desired task is changed back to 1 as we have configured the count of task to 1. It will run quite a while, and we just pause the videos here. Now we can see the running task is 1, and let's just check the task via the console. It is running. And check the logs, which look all good. Now we refresh the browser and we can see the site is up. We can also check the target group, and we can see the health check, and the health target is 1. Back to the containers of the task. The health status of the container is shown unknown. This is because we did not configure health check for the container. Now we can simply add below health check under image section. Now let's create a code pipeline using AWS Copilot. Actually, the command is pretty simple. We first run Copilot pipeline init and give it a name. And here I will select workload as we are deploying the services. Then we select test environment. Done. Now we have a pipeline directory which includes the manifest and build spec YAML file. If you are in the correct branch, you don't need to change anything to the file. But for our example, I would like to build a pipeline whose code source is from develop branch. So I need to check out a new branch and push the code to the develop branch. Then we can run the Copilot pipeline deploy. It pops up a required action where we need to authorize AWS to GitHub. We go to the code pipeline and select connection under settings, update pending connection, install new app if you don't have one, select the user or organization. We can also limit the access to the GitHub repositories, save, and then connect. Now the status is changed to available. Back to the terminal, I just noticed we are in Django start branch when we run Copilot pipeline init. So here I need to change the branch name to develop and rerun pipeline deploy command. It will be very quick. We push the code to the GitHub repository. Then let's check the code pipeline, which is built by Copilot. The build and deploy process will take some time to run, and let's pause the videos here. Now it should be ready soon. Let's just quickly check the status of the new task. The health status is still showing unknown. Okay, and let me try a refresh. Now you can see the status is healthy, which means the added health check in the manifest is now deployed. Back to the pipeline, the deployment is done. Let's go to the browser and the website looks good. Then the final thing we're going to do is to create our first view for the website locally and then use the Copilot created pipeline to deploy the new code. I will first run docker compose up-d-build. Go to the browser. The local environment is ready to use. As we are using Docker environment for the local dev, now we needed to create a new app. So we need to run the Django create app command within the container. So we do docker compose execute -w with the work directory Django, which is the container name, then Python managed start app my app. Now you can see the new app is created under the Django project folder. You may be not familiar with Django, so you can just follow me. So first, we need to create a view using HTTP response in views.py. In order to call the view, we need to map it to a URL. So we create a URL's Python file in my app folder and add the code. Then the next step is to update the root URLs. Here we use include function, which allows referencing other URL configurations. Once it is done, we first check the local host and the new view is created successfully. Then we push the code to GitHub. Now let's go to AWS code pipeline and we can see the deployment was just started. The deployment will last a few minutes and we just pause the videos here again. Okay, now the deployment is done and let's check the site. Yes, we have the new code deployed in the test environment. Cool, that's all for the video today. And if you are interested in more advanced usage about AWS Copilot, I would suggest you to go through the document here. Also, you can check my GitHub repository, which includes the step-by-step guidance and the links in the description. Finally, hope it is not too late. If you find the videos helpful, don't forget to subscribe to my channel and give me a thumb up to show your support. If you have any questions about cloud or DevOps, please leave your comments below and I will get back to you as soon as possible. Thank you very much and I'll see you in the next video.